Hi friends, how are you? Let's balance one more equation. The equation is for the reaction between potassium hydroxide and chlorine to form potassium chloride, potassium hypochlorite and water. First of all, we can list out the atoms of the reactants and the products. The atoms are potassium, chlorine, hydrogen, then oxygen. At the left hand side, how many potassium atoms are there? Only one. At the right hand side, the potassium is present at two different places. Please remember this point. When an atom is present more than one place, we need to check whether the number of atoms are in even number or odd number. If it is even number, we can write as it is now the total number of potassium atoms here at one place in KCl one atom, in KClO one more atom. Therefore, two atoms are there. Two atoms we can write together. If the total number of atoms is in odd number, then we need to split that number of atoms. So that rule we need to follow. The next atom is chlorine. At the left hand side, two chlorine atoms are there. And the right hand side, here also chlorine is present at two different places. But when we count, the total number is 1 plus 1, 2. It's the even number. Therefore, we can write as it is. We need not split. The next atom is hydrogen. At the left hand side, only one atom. At the right hand side, the hydrogen is present in water. That is, the subscript 2 denotes two atoms of hydrogen. The next atom is oxygen. At the left hand side, in KOH, only one atom is there. But the oxygen at the right hand side is present at two different places, in KClO and in water. But the total number of oxygen atom is 2 only at the right hand side. That's even number that we can write as it is. Now let's check both the sides which atoms are not equal. So while we are balancing, we can give priority to the metal atoms. So the right hand side potassium is 2 times, but the left hand side just only once. Therefore, what we can do that we can multiply this 1 by 2. So as a result, it also will become 2. So this 2 we need to write as a coefficient for this K. So where is this K present? In KOH. So this 2 has to be written as the coefficient of KOH. The next one, chlorine, both the sides equal. Hydrogen at the right hand side, 2 atoms, but the left hand side, only 1 atom. Therefore, what we need to do, this 1 has to be multiplied by 2. So this 2 we need to write as a coefficient for this hydrogen. Sorry, while we are multiplying this potassium hydroxide by 2, what change takes place? This 2, coefficient 2, belongs to potassium, oxygen as well as hydrogen. So as a result, Oxygen atom will change at the left hand side. Hydrogen atom will change at the left hand side. So oxygen at the left hand side, how many times? Already it was mentioned one. That will become, sorry, I have erased that once again. So oxygen already it was mentioned one. But now after multiplying by this two, this oxygen will become 2 times at the left hand side. Similarly, the hydrogen also will become 2 times at the left hand side. Just we have multiplied this potassium alone with 2 times. When we are multiplying this potassium hydroxide by 2, then all the other atoms automatically become equal. Now, potassium, at both the sides, the number of atoms are 2. Chlorine, both the sides, the number of atoms are 2. Hydrogen, both the sides, the number of atoms are 2. Oxygen, both the sides, the number of atoms are 2. So all the atoms of the reactants as well as the products are equal. Therefore, this equation is balanced. Now it is balanced. So the balanced chemical equation for this reaction is 2 moles of potassium hydroxide plus 1 mole of chlorine gives 1 mole of potassium chloride and 1 mole of potassium hypochlorite and 1 mole of water. Thanks for watching.